All right, we're going to go on to our next section, 3.14, and it's about estimating fraction division. This one was a little tricky for me because there are two different parts to it. Let me explain what I mean, and let's start by writing on our paper. We are doing 3.14, and we're doing estimating with fraction division. So again, we are going to be using those, common benchmark fractions, and those are going to allow us to estimate whatever we're up to. So remember, our common benchmark fractions, that's when we take any fraction, we turn it into either a 0, a half, or a 1. And when we're multiplying and dividing, it's going to give us a pretty good estimate of that number anyway. What's tricky about this one, that took me so long to figure out so I can show you guys, is that there's kind of two different steps for two different styles of division problems. First, let's quickly refresh our memory about common benchmark fractions. So if I'm going to look at 7/8 and I want to turn that into one of these fractions, I should know that 7 is almost 8 because it's 1 away, and it's probably 1. But if I needed to check myself, I can build an exact correlation between 0, half, and 1 for each of these numbers. For example, if I was using eighths, I could say 0/8 is the same as 0. For a half, I can take half of my denominator, 4/8, and for 1, I can do the full fraction. My numerator and denominator are the same. So here, I can look, 7/8 is definitely closest to 8/8, so I can approximate 7/8 into a 1 whenever I am doing my estimation or approximate work, right? Okay, so now we have two different ways to estimate fractions. We have one way here and a second way here. And this is all for dividing fractions, but there's two important differences, or one important difference that will determine where we go. In this side, we're going to do just fractions. And on this side, we're going to do the numbers that have when we have mixed numbers. And in both of these, we are dividing. All right, for example, let's take a look at these two different ways to do this. If we are just going to do fractions, we go like this. Our step one is we're going to rewrite the division problem as multiplication. Rewrite division as multiplication. Number two, we're going to approximate the values. And then finally, we multiply. Let's take a look at what that looks like here. We're going to do 7/8 times 1/3. 7/8 divided by 1/3. Okay, so our first thing that we need to do is rewrite this to make sure that we keep it accurate. We are not going to approximate yet, because if we do that, we're going to lose a lot of information in our problem. So we're going to rewrite this first. So I have 7/8 times 3 wholes. Okay, now I can approximate the values of these two numbers. 7/8, like I saw earlier, is I can rewrite as 1. 3 wholes is not really a fraction anymore. It's kind of a whole number. So I can rewrite that as 3, because it's not going to be 0, half, or 1. It doesn't have any extra fraction. So now I have 1 times 3, and that's easy. It gives me a 3. Make sense? So this only works, though, when I just am starting out with fractions. When I'm going to be doing it with mixed numbers, I have an additional step, and my order is slightly changed, and that's where it was very confusing for me. Our first step is that we're going to approximate the mixed numbers using benchmarks. Common benchmark fractions. So notice we do that first this time, which is a little bit different. Our second thing we're going to do, convert to improper if necessary. Often we don't. If we don't have any fractions after we have estimated, we don't have to even switch it to fractions. We can just multiply, which is really nice. But here, if we are doing the numbers so that they have, if we end up with a half in one of our numbers, we will need to convert our number. Our third step is that we are going to rewrite division as multiplication. And then finally, multiply. Let's take a look at an example and see how that looks here. Let me make sure I have the whole page on here. All right, I'm going to take the problem of 2 and 4/11 divided by 1 and 7/8. All right, my first step, just like I did before, is to, not like I did before, differently. I'm going to approximate my numbers using common benchmark fractions. So let's start over here. 2 and 4/11. Okay, 4/11. I'm not sure where that's going to be, so I'm going to check. Is it closest to 0/11, 5.5/11, or 11/11? Remember, I got this using the same way that we found our common benchmark fractions, and have found them this whole time. Well, 4 is definitely closest to 5.5. So I can rewrite this as 2.5 divided by 1 and 7/8. Well, this is 7/8 again. We already know that's going to be 1. 1 plus 1 is 2. So now I have 2.5 divided by 2. Okay. Number 2, convert to improper fractions if necessary. Unfortunately, it isn't necessary here because I do have mixed numbers and fractions. If it was just 2 divided by 2, I would have been okay. So now I have to convert. This is going to be 2 times 2 plus 1 over 2 divided by 2 over 1, because I can rewrite this as a fraction. This turns into 5/2 divided by 2 wholes. Okay, now rewrite division as multiplication. So remember, when I do that, I have to take the reciprocal of my second number. Now I have 5/2 times 1/2. And now I can just multiply just like I normally do. 5, 2 times 2 is 4. Okay, I need to turn it into a mixed number again. So I'm going to pull 4 out of that 5. So I have 1 and 1/4 for my answer. Notice when I have mixed numbers, it's going to have more steps and it's going to be more difficult. I recommend keeping this around so that you can remember which way you are doing it as we do our examples. All right, let's take some examples and get started. I'll try to do 2 and then set you free if you feel like you get it. Okay, example 2. Sorry, example 1. We're going to do 7 and 7/8. A lot of 7/8 today. Divided by 4 and 5/9. Oh, right. We are definitely using our second method because we have mixed numbers instead of just fractions here. Oops, I was off the page a little bit. All right, so 7 and 7/8. 7/8, I know it goes to 1. So I have 8 divided by 4 and 5/9. Well, I think that's going to be a half. Let's check. 0/9. Half of 9 is 4.5/9, and the whole thing would be 9/9. Yeah, 5 is definitely closest to the middle. So I have divided by 4.5. Ugh. So now I have that fraction here. I have to go through that long process of turning into improper fractions instead of just multiplying, unfortunately. All right, so let's do that. We have 8 wholes over here, and we need to turn this into a mix or an improper fraction. So 4 times 2 plus 1 is 9/2. All right, because remember, Convert to improper fractions if necessary. Unfortunately, it was. Rewrite as multiplication. 8 wholes times 2 over 9. Okay, and now multiply. Okay, we can do that. 8 times 2 is 16. 9 times 1 is 9. All right, let's take a look. I need to pull out my 9 from here. So I have 7 ninths, 1 and 7 ninths for my answer. Make sense? Okay, let's do another one. Example 2. This time, we're going to estimate 8 ninths divided by 1/2. All right, what's kind of nice is this time we can use our just fractions symbol. So our first thing we're going to do is rewrite them. So I'm going to do 8 ninths times 2 over 1, because that's what I do when I take the reciprocal. I'm going to approximate the values. 8 ninths, well that, if I take my common benchmark fractions, I can see is going to turn into a 1, right? Because if I do 0 ninths, 4.5 ninths, and 9 ninths, I can definitely see that 8 is closest to a 9. So I can write 1 times, this just turns into a 2. Well, this is super easy, so I can just write my answer as 2. Notice how much easier it is when we just have fractions. Okay, I think I can fit one more example on this page. If you feel like you understand it, go ahead and go on. I'm going to do maybe 2 more or so, depending on if I get tired of this. We'll see. Okay, let's look at another one with mixed numbers. We have 5 and 5/6 divided by 2 and 3/4. Oops. 2 and 3/4. All right. So this one we are definitely going to be using our dividing mixed numbers over here. So we need to turn, so let's check out. All right, I almost made a mistake. Good thing I have my rules. Approximate my mixed numbers. Okay. So this 5/6, that's going to turn into a 1. So I'm going to have 6 divided by, well, 2 and 3/4. 3/4 is close to 1. So I'm going to turn that into 1 and a 2, which gives me 3. Oh, look at that. And this time, convert to improper fractions if necessary. It isn't, because I don't have any fractions. And 6 divided by 3, well, I know that to be 2. Done. Easy. Okay, let's look at one more tricky one, using those mixed numbers and then having to do that extra step or so. We'll see what we get. I forgot which ones we already did. Let's see. Let's do 2 and 4/11. Example 4. Divided by 1 and 7/8. All right, so for this one, we are gonna, I feel like I did this one already. I did, it's right there. Which example am I missing? Ah, here we go. Well, we'll just make one up. Example 4. Let's take a look at 3 and 7/8 divided by 2 and 3/7. All right, so looking at this, our first step is that we're going to approximate both of our numbers. 3 and 7/8, well, I've done 7/8 4 times already, so I know that turns into a 4 really easily. 2 and 3/7, if I'm going to build my common benchmark fractions, it's going to be 0/7, 3.5/7, and 7/7. So 3 is definitely closest to the middle, so I'm going to have 2 and a half. Ugh. So this time I need to turn it into an improper fractions. Convert to improper fractions. So let's do that. I have 4/1 divided by 2 times 2 is 4 plus 1, 5/2. Next thing, rewrite. All right, so I have 4 wholes times the reciprocal, 2/5. And then I finish off with a multiply. 4 times 2 is 8. 1 times 5 is 5. Okay, I need to turn it back into a mixed number, so I'm going to pull 5 out of that 8. So I have 1 and 3/8. Cool? Hopefully that makes sense. If you have any questions, ask.